increase in your services? Are there more movies talking about math and science?
So we don't really get people contacting us all the time. It's very rare, in fact, that it happens. But the U.S. government got in on the act. So they created something called the Science and Entertainment Exchange. And then they became consultants for lots of movies, like Marvel movies, movies with giant budgets. And more people haven't been contacting us, but clearly more people are contacting other people who are doing the same kind of work. They're not as good as we are, of course, but I'm not just saying that as a joke, but it's really true. But the Science and Entertainment Exchange is a big outfit because they've got the resources of the U.S. government.
I remember you told me a story about a film that you wanted to consult for, but they didn't take your advice.
So I don't remember, but there was a movie starring the guy who played Frodo in Lord of the Rings, called The Oxford Murders. And this was a novel. I think it won an award. I actually knew the author. Not only did I know the author, I have one of his preprints, which he never published. He's a mathematician. He was actually working in my field, lattice theory. So he wrote this novel, and then I got contacted by a producer about being a consultant for it. But alas, that producer himself got cut out of the movie. He didn't, somehow they went forward without him. So in the end, we were not consultants for this movie, but we would have been the absolute best consultants for the movie, since I knew the author. He even put my supervisor in the book, with a pseudonym, but a character like that. He mentioned other people that I didn't know in the book. People who like lattice theory, in fact, who were mentioned by name in the book without not a pseudonym. And but they had a ridiculous scene where Frodo stands up in a lecture hall and says, "I believe in pi," P-I. And it's a laughable scene. You would never see a mathematician doing this. Moreover, and this is the important point, this is what I like to say when I tout my company, Hollywood Math and Science Film Consulting. A popular newspaper, I think the Daily Telegraph, but a major newspaper mentioned how ridiculous this scene was. So even lay people could see that this was absurd, and obviously a negative review in a major newspaper is going to hurt your ticket sales. So if they had hired us as consultants, that scene wouldn't have been in the movie, and they would have avoided that negative review and maybe made a lot more money. In the end, the movie was never released in the U.S., just the UK.
Do you know that movie, Oxford Murders?
I don't think so.
I remember.
Yeah.
Strange. Do you, what was his name? You know the physicist, James Sylvester Gates?
I can't say I know him. I have communicated with him.
Oh, okay.
Yeah.
He, in an interview, he said when he was a kid, he saw in an encyclopedia book the Schrödinger wave equation, and he wanted something so strange and foreign, like excited him. So he wanted to investigate it more. So that drove him to try to learn physics.
Oh, interesting.
When you were young, do you remember anything like that? Seeing something that was beyond your, way beyond what you knew, and striking curiosity?
Actually, when I was in high school, I was at one of these competitions in New York City, and I saw someone with a T-shirt with the Euler's formula, e to the pi I equals -1, or some variant of that. And I couldn't believe it. I thought, there's no way that could be true.
I thought the same thing when I first learned that in a math video I saw on YouTube, and I thought that was incredible.
Yeah.
That was a very, maybe the most powerful math moment in my life. That was really, made me see things differently. That was motivated me to want to do math more. I think things like that would help kids pursue math with more ambition than some of the, I don't know, some of the more traditional ways of marketing math.
Yeah, so the way math is taught in school is terrible. You know, they'll show you a picture of a triangle and then say, prove it's a triangle. And it's like, or you know, or prove it's a right triangle, but you can look at it and go, yes, it's the right triangle. What am I supposed to actually be proving? Whereas there are lots of interesting statements they could have people try to understand. That might be one of them. Once you can explain to students what pi is, they might be a bit harder to show them what E is all about, so they can appreciate that more. But I is a simple concept, and that sort of thing would amaze them. I actually think that they should teach more discrete math to high school students. So rather than have calculus be the epitome of high school mathematics, why not have someone learn about, you know, the four-color theorem or something like that in high school math? And they're still learning about math. In fact, it's closer to the frontier of math than calculus, which was done hundreds of years ago. But, you know, mathematicians, well, actually now there are mathematicians who advise schools. 20 years ago that wasn't the case. 20 years ago I estimated that maybe half a dozen research mathematicians cared about K-12 education. But now plenty do. So there isn't really an excuse for not changing it, but they haven't.
I've heard somebody say almost the same thing. They said instead of culminating at calculus, they should culminate at like probability and statistics.
Okay, yeah. I mean,
they say it's more immediately useful.
Oh, yeah. So I'm not saying that they should do something that's useful. In fact, I sort of don't like that attitude. I think, if anything, we should tell students we don't do math because it's useful. Just like you don't read philosophy because it's useful. Or study art because it's not useful in that sense, that direct, everyday sense. It's more like, it's not useful in the sense that eating bread is useful. It's useful like, you know, feeding the soul is useful. And no, unfortunately, math can't be as readily appreciated as a painting, but or film. But we should explain to students that there are people who see it that way.
Yeah, a lot of my appreciation for math came in the later years when you learn the kind of the rich concepts of higher level math. Because when you're young, you learn like arithmetic, computation.
Exactly.
Like you're just instructions, do this and this and that.
Yeah.
It's not as fulfilling as higher level math.
I mean, I still enjoy those computations, and the students today can't do those computations because they just rely on their calculators. They just reach for the calculator and try to do something, and then they have no idea what the calculator is actually doing. But yeah, proving theorems is more interesting than numerical calculations.
Mm-hmm. Well, I think that's why I had to do the assignment in the first day of math.
The multiplication thing.
On the first day of my math class in 6th grade, I was in the wrong class because I messed up my schedule, so I was going to be leaving it in 2 days, but I had to do the homework assignment.
Yeah.
And the first day's homework assignment was like 40 problems, and it was all like 452 times 898 or something, and you have to show all your work.
Yeah.
So I just
like
remember doing that on the first day, and I knew I wasn't even going to be in that class, but I had to write all of it.
But that's actually good, and that's what I think they don't do anymore.
When you told me that story, my immediate response was, oh, that's a pain in the ass. But now when I think about the students that I teach, I'm actually like, you know what, they needed more of that.
Yes, they need more of that. They need more drills. But drills are out of fashion in educational circles. But the people who create curricula aren't mathematicians. At best, they're in math education, but they're not mathematicians. And so they don't really know what works. They're also focused on fun, making things fun.
I was gonna say, what did I have here? I know that math is rooted in logic. So math feels like a big logical exercise. And then there are the abstractions of math, you know, the symbols and